All right, hello everyone, it's me again, Michael, and we're going to be taking a look at one of the problems from the team round, so number 7. Evan rolls a pair of fair, standard 6-sided dice and adds the two numbers. If the sum is less than 7, he rolls the dice again and adds the new sum to the old sum, and repeats until the cumulative sum of all the dice rolls is at least 7. When Evan stops, the probability that the cumulative sum of Evan's dice rolls is exactly 7 can be expressed in the form m over n for relatively prime positive integers m and n. We want to compute m. Now, for this problem here, right, basically we're just rolling pairs of dice, and then we record the sum after each pair of dice is rolled, and we stop once we hit 7 or more. Right. So essentially, we can break this problem down into 3 cases, and that is we roll 1 pair of dice in total, or 2 pairs, or 3 pairs, right? Because if we roll the pair of dice any more than 3 times, then the minimum sum is 8 ones, which is 8, which is more than 7, and therefore that will not impact our probability. So we can see that the probability, right, that we roll a 7 with 1 pair of dice is going to be 1/6. We can roll anything on 1 dice and the other one, as long as it adds to 7, we're good to go. Now, the harder part comes when we have to deal with 2 pairs of dice. So when we have 2 pairs of dice, that means we have rolled 4 total dice, right? So how can we have 4 dice such that the numbers that they show add up to 7? Well, we can have a 4 and 3 ones. We can have a 3. We can't have a second 3. We can have a 3, a 2, and 2 ones, or we can have 3 2s and a 1. Now, the number of ways we can order each of these, respectively, is 4 choose 1 is 4, 4 factorial over 2 factorial is 12, and then 4 choose 1 again is 4. Now that means that 4 plus 20 plus 4 plus 12 plus 4 is the total number of ways we can get 4 dice rolled with a sum of 20, and that's out of a total of 6 to the 4th. So this will give us 20 over 6 to the 4th. So that's the probability that we end with a sum of 7 with 2 pairs rolled. And finally, we want to look at what happens if we've rolled 3 pairs. When we're rolling 3 pairs, the minimum sum is 6, and we want 7, which just means that one of the rolls is a 2 instead of a 1. The number of ways we can order this is going to be just 6 choose 1 is equal to 6. So therefore, the probability of this happening is going to be 6 over 6 to the 6th, which is going to be 1 over 6 to the 5. Now, the total probability, since these 3 events are disjoint, we can't simultaneously finish with having rolled 1 pair and 3 pairs. For instance, that means our total probability, right, that will give us m over n is going to be 1/6 plus 20 over 6 to the 4th plus 1 over 6 to the 5th. And if we combine those into a fraction, we get 6 to the 4th plus 6 times 20 plus 1 over 6 to the 5th. We note that because of the 1 at the end, the numerator and the denominator are already relatively prime, and therefore we can see that m is going to be equal to 6 to the 4th plus 6 times 20 plus 1, which is equal to 1296 plus 121, and that's 1,417. So that means that our value for m is going to be 1,417.
This is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.